Here's another integral. This is a rational function. Um, there's nothing really obvious to do here, I don't think. You could make u equal x minus 7, so du is dx, which would mean you have the integral of 5x minus 2 over u du. So those are the substitutions from our u's. And then you could think, well, if u equals x minus 7, then x equals u plus 7. So you could make this 5 times x is u plus 7 minus 2. And then you could multiply all that out and split up the fraction, and this will work. So that's one way. I'm not going to do it that way because I think there's a better way, but that would work. So the one thing you should notice here is this is an improper fraction because the degree of the top is equal to or bigger than the degree of the bottom. So whenever the bottom degree is not bigger than the top, it's improper. And a lot of times with improper fractions, if you divide them and then integrate the result, it's easier. So I'm going to do that. You can do this one synthetically. I'm doing it with long division. So 5x minus 35, subtract these, you'll get a remainder of negative 2 plus 35, which is 33. A synthetic quickly, because it's easy, would look like this. Bring down the 5, multiply the 7, 35 plus the negative 2 is 33. So either way, the result is the quotient is 5 plus the remainder over the divisor. So that's what we're going to integrate now. Now that's pretty easy because it's a sum now, so you can integrate this part first and then integrate this part second. So the integral of 5 with respect to x, remember, is 5x. Then the integral of 33 over x minus 7. You can use u substitution for this, but if you notice, the derivative of the bottom is 1. We have 33 up top, so that's just a constant. And you don't have to show this step. But this is now u prime over u. So it's an easy integral. It would be 33 plus the natural log of the absolute value of the bottom, and then you're done. 5x plus 33 natural log of the absolute value of x minus 7. Did this on Wolfram alpha. Now you notice, again, if you're checking with Wolfram alpha, it's a little bit different. They have 5 times the quantity x minus 7. And that's just something, I guess, in their algorithm. So if you could change this part to 5x minus 35 plus 33 log of x minus 7. But the big thing is here you have to plus the constant. So if you could subtract this 35 from the constant because it's also a constant, and you still have any constant. So that's why Wolfram looked a little different. But this is probably the better of the two answers. It looks a little bit more simplified. There you go.